Welcome to Unit 2 of Module 8 of Communication Research. Dealt in this unit are the 4 probability sampling methods and 3 methods of drawing random samples. Sampling is the process of selecting a representative sample from a study population to collect and analyze data in order to understand and make a generalization about the population. As explained in the earlier unit, studying population is both expensive and time consuming. Hence, researchers have developed a variety of sampling methods or designs which are grouped under 2 broad categories: probability sampling methods and non-probability sampling methods. As the non-probability sampling methods will be dealt in Module 9, this unit focuses on the various types of probability sampling methods. To understand probability sampling, one must know what probability is. The probability of a given event is the known frequency of occurrence of an event among the events of the same sort. The probability of event is stated mathematically as a ratio. For instance, the probability of a coin falling with head or tail is 1 by 2, that is 50% or 0.5. Likewise, the probability of selecting a student from a batch of 32 students is 1 by 32, which approximates to 3.22% or 0.032. In the probability sampling, each member of the population will have an equal and independent chance of being selected into the sample. Equal implies that all members of the population will have the same choice of being selected to constitute the sample. Independent means that the choice of one individual will not affect the inclusion or exclusion of another individual. Probability sampling has 2 advantages. The first advantage is that each member of the population will have an equal and independent chance of being selected into the sample. As a result, bias in the selection of samples get reduced. And the second advantage is that the probability of the sample representing the population increases. These 2 advantages are common to all probability sampling methods. There are 4 probability sampling methods: simple random sampling, systematic sampling, stratified random sampling, and cluster sampling. Let's understand these 4 methods. Simple random sampling is the simplest of all probability sampling methods. At the outset, it must be noted that the word random is, as used in random sampling methods, does not mean haphazard. Instead, random denotes a systematic selection process in which each unit as well as every combination of the units of a population will have an equal and known probability of being selected into the samples. Samples drawn through this method will have the advantage of being free of selection bias and representing the population to a great extent. It is the most appropriate method for drawing samples from homogeneous population. Simple random sampling has a disadvantage too. It can be used only when the sampling frame, that is a complete list of the individuals of the population, is available. For large populations, such lists are not available in the public domain. Hence, researchers have to go through the challenging process of seeking the permission of the concerned authorities to obtain the list. In such situations, simple random sampling will be a time-consuming and tedious process. In simple random sampling, as well as in other random sampling methods, samples get drawn through one of the 3 methods. The 3 methods are lottery method, random number table method, and computer-aided method. Lottery method, also known as the bowl method, is the oldest of all probability sampling method. It has a simple procedure. If the population has 100 individuals, each person's serial number is noted on a small slip of paper. The 100 slips are rolled and put into a box and thoroughly mixed. If the sample of 15 is required, one sample is picked at a time from the box and the number is noted. This process is repeated to select the remaining 14 individuals. Random samples drawn through the lottery method can be drawn with replacement or without replacement. In sampling with replacement, the slip of the individual selected in each draw is kept back in the box before drawing the subsequent one. Replacement will ensure that all members of the population will have the same probability of being selected in each draw. In sampling without replacement, the selected members in each draw will not be kept back in the lottery box. As a result, the probability of selecting the individuals in the subsequent draw goes on decreasing. For instance, in a population of 100, the first individual will have the probability of 1 by 100. As the slip of the first individual selected is not kept back into the lottery box, the probability of selecting the second individual will get reduced to 1 by 99, and that of the 15th individual will be 1 by 86. However, as the chances of an individual getting selected more than once will be low, samples without replacement can be drawn and used. The lottery method is the best suited when the population is small. When the population is large, running into thousands, the lottery method will prove to be a cumbersome process. Let's look into the random number table method. All random number tables will have numbers organized in rows and columns. A small part of the random table shown here as a set of 30 numbers arranged in 6 columns and 5 rows, where each number set has 5 digits. If the size of the population is 50,000, 5-digit numbers which do not exceed 50,000 qualify for selection. If the size of the population is 500, only the first 3 digits or the last 3 digits which do not exceed 500 qualify to be selected. Let us assume that we need to draw a sample of 15 from a small population of 500 students who have been assigned a number from 1 to 500. 500, as you know, is a 3-digit number, and we have decided to begin from the first column and select the first 3 digits of the number set which do not exceed 500. Fulfilling this criteria are 15 numbers sets whose first 3 digits are 116, 221, 104, 367, 363, 444, 262, 47, 332, 120, 376, 263, 88 and 316 and 283. The students listed against these numbers in the sampling frame of the population will constitute the study sample. Though simple, the popularity of random number tables has receded following the development of user-friendly computer software for generating random numbers. Let's learn about the computer-aided method. Computer softwares have made the process of drawing random samples far simpler. Scores of websites such as stattrack.com have random numbers generating pages that generate the required size of the sample. In most websites, one need to enter the details such as how many random numbers required, that is sample size, the first and the last numbers of the population, and whether duplication of number is allowed. Once the details are entered, the user needs to press the calculate or go button. In a jiffy, the required random numbers get displayed as shown here. Individuals listed against these numbers in the sampling frame will constitute the random sample. Let's go to the second method of probability sampling known as stratified random sampling. Stratified random sampling is a method of sampling in which the population is divided into groups known as strata which share a common characteristic. Generally, the population is stratified with regard to the study variables such as gender, age, income, education attainment, employment status, or reading preferences of newspapers. For example, based on the gender variable, the population gets divided into 2 homogeneous strata of male and female. The male stratum will have only males and the female stratum will have only females. Hence, a stratified random sample will have 2 significant advantages. It is likely to be more representative of the population as it ensures better coverage of the population than a simple random sample. Consequently, stratified random sampling reduces sampling error as all strata of the population are represented in the sample. It has a disadvantage too. The researchers must have a knowledge of the strata and their composition, and it is a tedious, time-consuming process. There are 2 types of stratified random sampling: proportionate stratified random sampling and disproportionate stratified random sampling. Let's look at the third method of cluster sampling. When a comprehensive list of a large and widespread population is not available, cluster sampling method serves well in drawing random samples. Cluster sampling is a multi-stage probability sampling method in which the whole population is subdivided into groups known as clusters. For example, let us take the case of a study aimed at assessing the usage of social media among postgraduate students pursuing courses in universities and colleges across India. In this study, there will be several clusters such as Indian states, universities, colleges, postgraduate courses, classes and students. The required sample gets selected in several steps. First, the required number of states will be randomly selected. From the selected states, the required number of universities will get selected. Then a required number of colleges will be randomly selected from the selected universities, and from the selected colleges, postgraduate classes will be randomly selected. Finally, a sample of students will be selected randomly from the chosen classes. Cluster sampling process may appear to be long drawn. However, it is less cumbersome process as the sampling frame of Indian states, universities and colleges of the university will be available. Also, obtaining a list of students from chosen colleges will not be difficult. As a result, cluster sampling is a cost-effective and time-efficient probability sampling method. For these advantages, cluster sampling is generally used in survey studies. A major disadvantage of this method is that it is likely to have a relatively higher sampling error than the stratified sampling methods. Let us understand the fourth random sampling method known as systematic sampling. Systematic random sampling is a method in which every nth number of the population is selected. In this process, the first member of the population is selected randomly and subsequent individuals are selected at a fixed interval called as the sampling interval. The sampling interval is determined by dividing the population size with the desired sample size. Let us take an example. If the population size is 100 and the required sample size is 20, the sampling interval will be 5. To sample 20 individuals, a starting point is randomly picked in the list of 100 individuals. If randomly picked starting point happens to be 3, then every fifth number beginning from the third number will be chosen. In this case, the 20 numbers will be 3, 8, 13, 18, 23, 28, 33, 38, 43, 48, 53, 58, 63, 68, 73, 78, 83, 88, 93 and finally 98. These individuals listed against these numbers will constitute the sample. The procedural simplicity is the strength of the systematic random sampling method. If the individuals are listed in the population on some criterion, systematic sampling may yield a non-representative sample. This is the potential weakness of the systematic sampling. There is disagreement in classifying systematic sampling as a probability sampling method. Some consider it as a probability sampling method as its procedure resembles simple random sampling procedure. As we have come to the end of the module, let us summarize. Study samples will have a bearing on the outcome of the study. The representative nature of the samples to the study population and its size matter in the calculation of sampling error and in generalizing the findings to the population. Such being the importance of samples, researchers need to choose the most adequate sample size through an appropriate sampling method. The two factors that determine the sample size are the desired level of confidence and the margin of error. In social science research, a confidence level of 95% and a margin of error of 5% is most often used. These two determinants are essential in calculating the required sample by using either the sample size formulae or sample size tables or web-based interactive sample size calculators. The sampling methods used are broadly classified into probability and non-probability methods. In probability sampling, every member of the population will have an equal known chance of being selected into the sample. There are 4 types of probability sampling methods, namely simple random sampling, stratified sampling, cluster sampling and systematic sampling. A thorough understanding of these procedural details of these 4 sampling types and their strengths and weaknesses will help students, researchers in choosing a method keeping in view the factors of cost and time and precisions of the result. The end note is, read the module text and the book suggested to enhance your knowledge.